and then G compose f of g of f of x. So I'll just replace f of x with the expression that it's equal to. And then if I do g of something, I'm going to take whatever's in g and replace that with, or put that where the x's are. Okay with that? And there's no more simplifying I can do there, so I'm done. Is that cool? Okay. Yes, Julia. 42? Sure. Is it just because you can't read the points? Yeah, because I can't read them either, so I would just say you can skip that one. How's that? Yeah, I think that when I looked at that, I think that's one I probably need to go back and improve the image on, because I don't think there's much you can do with it if you can't read the points. So that'll do though. If you could read the points, would you know what to do? You can tell if it's a function or not, right? No, I think it's just points. For number 42, it should just be like, it looks like it's 5 ordered pairs. And that should be easy to deal with, right? Yeah. So, okay. That was a disappointing answer to a reasonable question. Unfortunately, you can't read it, so what are you going to do with it? I need to do a better job and to go back and fix that one. Anyone else? Okay, that's fine. If you guys would, if you can take out your tablet and open up your OneNote to the content library. So open up your tablet, open OneNote, go to the content library, find the section that says Chapter 1 Homework Quiz 1, and you'll want to copy that page then into your section of OneNote and answer that question in OneNote. If you don't have a stylus, do the best you can without a stylus, but we asked everybody to get one. It's been over a week, so hopefully you've got that part taken care of. If you haven't, use your finger or or your mouse, because you've copied this and pasted this from OneNote. This is just a OneNote file. So if you need more space, you can just press like enter in between this stuff and it makes more space, right? We'll give you guys, 10 or 15 minutes here to kind of work on these 2 questions. And at that point, I'll tell you how you're going to turn this in. Okay? If you get stuck on something technology related, let me know and I can assist you. Sure. Thanks. Is there anything worse than sneezing in a mask? It's pretty gross. All right. Even if some of you guys are still working, I want to just explain to you how we're going to turn this in, because from body language, it seems like maybe the majority of us have finished working on things. So even if you're not finished, listen to how we're going to do this so that when you do finish up here in the next 5 minutes or so, you're able to turn this in. It's been about 15 minutes here, which is not an unreasonable amount of time to do with 2 questions that you've likely done before. So what we're going to do, in the upper left-hand corner of OneNote, you're going to see the File option. See the word File? Go ahead and click that. On the side here, on the left, there's a list of commands. We're going to choose the Export command. And from the file type selector in the middle, we're going to pick the PDF option. And then you're going to hit Export. That's going to ask you to choose a location to save this file to. My suggestion would just be to save it to your desktop, so it's easy to find and then get rid of after you turn it in. So I would just put it on my desktop and then go ahead and hit Save. Once you've saved your PDF to the desktop, go to OneNote. You'll find there's a homework quiz 1 assignment in the Dropbox, and you just load that PDF file right up into that Dropbox. Everybody okay with that? Again, if you get stuck or if you have questions relating to technology, that's fine. You can come up and talk to me or ask a question. We're going to say that the absolute deadline for this is 1:55, so 7 more minutes for you to finish up what you're doing and get that sucker into the Dropbox. And then we're moving on. Okie dokie? Artichoke. Okay, so it's 1:55, so we're done with this first homework quiz. Hopefully that wasn't too painful. The questions should have looked rather familiar, as they're things that we have done before to some extent or another. Let's move on here and finish up the chapter 1. The last section in chapter 1 that we still need to talk to is about graphical transformations. So if you recall back from your geometry class, there were 4 types of transformations. Does anybody remember one of those 4? Well, I'll start. There's the translation. That's where, like, you pick the figure up and you move it left or right or up or down, but the orientation of the figure still stays the same and the location changes, but the size also stays the same. So size and orientation are fixed, but the location moves. Does anybody remember another one of those? Reflection is another one. Great. So in a reflection, the orientation can change and the location can change, but the size will stay the same. What's another one? Starts with an R is another one. R-O. That's it. Thank you. Rotation. In a rotation, the orientation will change and the location can change, but the size of the figure still stays the same. And then the last one starts DIL. Dilation is the correct answer there. In a dilation, the size is going to change, but the orientation should stay the same. And obviously the location of the figure will change because the vertices would now be in like new locations, right? You guys kind of remember that way back from geometry? I know that was a long time ago. In this kind of a class, we're going to only worry about transformations to functions that involve reflections, translations, and dilations. We're not going to worry about rotations. That's actually a really difficult topic to talk about. Taking a graph of a function, like rotating it like 30 degrees about some point. You really kind of need to have some linear algebra tools in order to do that effectively. And it's beyond the scope of a class like this. So if you remember way back from your geometry class, we also wrote transformation maps to describe how you would take your original points and transform them. So for a translation, you're just going to add to the x and y coordinates. In this class, we're going to worry about 2 types of reflections, those where we reflect across the x-axis and those that we reflect across the y-axis. To reflect across the x-axis, we're going to negate the y-coordinate. And to reflect across the y-axis, we're going to negate the x-coordinate. And then a dilation is going to be like a scaling. So we'll multiply the x-coordinate by something and the y-coordinate by something. Those 2 numbers could be the same number, keep in mind. I think that's in geometry what we always did was the scale was always equal to the x and y direction. But there's no need that needs to be the case, and in this class it won't always be the case. The scaling could be different. to the x and to the y. Everybody, does this kind of ring a bell? Look familiar a little bit at least? That's all I'm looking for, is some vague sense of familiarity. Again, you didn't have to remember any of this stuff from jump. I wouldn't have expected that. But once we talk about it and we write this stuff down, you're like, oh yeah, I kind of remember that. That's all I'm looking for here. So, in an algebra class or this trigonometry and precalculus course, more often than not, when we talk about a function, we're not going to be describing it with like a set of ordered pairs, because more often than not, the functions that we're discussing are infinite. They'd have an infinite number of ordered pairs, and it's not very convenient to describe our function using that kind of notation. We're going to want to describe it using a graph or maybe an equation. These are ways that are much easier to kind of represent a function that contains an infinite number of points. So, to do that, or to reshape this in that fashion, imagine we have our basic function that I'm going to write as y equals f of x. We can refer to this basic simple form as the parent function. That's a phrase that maybe is familiar from last year. In your Algebra 3-4 course, did you guys mention parent function? Okay, I see some people shaking their heads. So we can transform any parent function to get a new resulting function using this basic framework, where these coefficients a, b, h, and k each control a different type of transformation, or result in a different type of transformation. So this guy is our transformed function. So the a value controls two things. If a is negative, we have a reflection across the x-axis. If a is positive, we have no reflection. But the sign on a is not the only thing we need to consider. We also need to consider the magnitude of a. So if the magnitude of a is bigger than 1, we have a kind of dilation that we'll call a vertical stretch. And if the magnitude of a is less than 1, we'll have a kind of dilation called a vertical shrink. And we should probably indicate the factor of that shrink. In this case, it's always going to be by a factor of a. And the only case that we haven't covered here is if the absolute value of a is equal to 1. So we should probably indicate no vertical dilation. Okay with that? Okay. The next thing up is the b's. So the b, again, does two things. So the sign of b controls whether there's a reflection across the x-axis. I'm sorry, I meant y-axis. I wrote the right thing and I said the wrong thing. The b's control reflections across the y-axis. My apologies. And the magnitude of b controls the horizontal dilation. So again, if b is bigger than 1, we have a horizontal stretch by a factor of b. And if the magnitude is less than 1, we have a horizontal stretch, shrink, It's the end of the day, guys. I'm tired. Are you guys tired? In case of the sleepies or something. By factor of b, and if b is 1, we have no horizontal dilation. Okay. And then the h's and k's, so if h is positive, we're going to shift right h units. Or if it's negative, we're going to shift left h units. And then the k also controls the translation, but up and down. So if k is positive, we'll shift up k units. And if it's negative, we'll shift down k units. Everybody okay with that idea? Okay. So let's say we have an example where my function f of x is equal to 3x squared minus 4x plus 1. And we want to, we'll do two of these, transform f of x with a vertical stretch of 3. And then let's say the other one will be with a horizontal actually, let me look here. Horizontal shrink of 1/2, and then a shift left 1 unit. So if I look at letter A, a vertical stretch of 3 tells me that the A coefficient should be 3, right? Everybody's okay there? So my transform function should be 3 times f of x. How did I get that? I'm just using this and filling in the values for A, B, H, and K, right? The only value we know about is A, so that's the only thing that I bothered to put in. Is everybody okay there? So I know that the function for f of x is 3x squared minus 4x plus 1, given to me in the problem. So I just need to distribute that 3 through, and that's it. Is that okay? If I do B, horizontal shrink of 1/2 tells me that B is 1/2, and shifting left 1 unit tells me that H is -1. How did I know negative? Because it's left. Is everybody okay there? So in B, I'd say g of x is going to equal f of 1/1/2 times x minus a -1. Now, 1/1/2 is the same thing as 2, and minus a negative is the same thing as a positive. And then if I distribute that 2 through, really I have f of 2x plus 2. Everybody okay there? So I'll just go ahead and do that. So if I have f of 2x plus 2, into my f of x, everywhere where there's an x, I'm going to replace it with a 2x plus 2. Everybody okay there? And then I just have a bunch of crappy simplification left to do. So let's see, what do we have here? 12x squared plus 24x plus 12 minus 8x minus 8 plus 1. Now I did some stuff in my head here that you'd probably need to write out, and that's fine if you need to write it out, no big deal. I just went and did some of that simplifying in my head. Do you want to know how I did in my head so quickly? This thing I thought of, instead of 3 times 2x plus 2 squared, I thought of it as 3 times 2 squared times x plus 1 squared. So 12 times x plus 1 squared. And x plus 1 squared is just x squared plus 2x plus 1. And then distribute the 12 through. I don't know. That's what I did in my head. Wow, how I was able to do that. Just in case you were curious. One of the perks of being a math teacher, right? So you get so much practice doing stuff like this, it gets easy to do in your head. I would not expect you to be able to do that in your head. Although if you can, that's fantastic. Does everybody feel okay about doing a problem like this where I describe a transformation in words that we're going to do on a function, how to actually find the new equation for it? It's not too bad, right? Usually the worst part is like the simplification like we had here. So if I ask you to describe a transformation in order, what I'm asking you to do is to describe what's going on, starting with the reflection of the y, and then the horizontal dilation, and the reflection of the x, and then the vertical dilation, and then the horizontal translation, the vertical translation. If you were actually to try to perform all 6 of these transformations by hand graphically, this would be the order in which you'd want to do it. So the first thing you want to do is flip it across the x, and then stretch it this way, and then you'd flip it across the y, and then search it that way, and then you move it left, and then you move it up, kind of thing. Now, I would never ask you to do that graphically in 6 steps, because that's a lot of graphing to do. Instead, what I'll just ask you to do is write the transformation in order. Okay with that? We'll do an example right here. Okay. So let's say we have the parent function f of x equals the square root of x. And I want you to write the transformation in order for g of x equals -3 times the square root of 2x minus 4 minus 2. So the first thing I'm going to need is to remember my basic form for any transformation. Everybody's okay there? The next thing I'm going to do is I'm going to want to try to write the transformation I have in this form. So the place that's not quite right is this part that's inside of the function, right? Can everybody see that? So the first thing I'm going to do is I'm going to look for a greatest common factor in that part that's underneath the radical. Well, hopefully everybody can see there's a greatest common factor of 2 inside that radical. Everybody's good there? But that 2 still doesn't look like a 1 over b. Everybody see that? So how can I rewrite 2 as its or as a like 1 over something? I can write 1 over its reciprocal, right? 1 over 1/2 is the same thing as 2. Everybody's okay there? So now looking at this, I can see that the a is -3, the b is the 1/2, the h is +2, and the k is -2. Now that I've identified, oh, I'm sorry. Did I use, yeah, okay, I did right b, okay. Now that I've identified this, I can say since b is greater than 0, I have no reflection across the x-axis or the y-axis. Since the absolute value of b is less than 1, I have a horizontal shrink by a factor of 1/2. Since the a value is less than 0, I have a reflection across the x-axis. And since the absolute value of a is greater than 1, I have a vertical stretch by a factor of 3. Since the h value is positive, we're going to go right 3 units. And since the k value is negative, we're going to go down, I don't know, right 3 units? Try 2 units, Goofus. And then we're going to go down 2 units. So this is like step 1, 2, 3, 4, 5, 6 in my transformation. So this is the final answer that we're kind of looking for. Is everybody okay with that idea? Really, the trickiest place is getting your transform function into that standard form so you can pick out the a, b, h, and k easily. And then from there, you're just using the rules that we had stated before, and that should be pretty easy to do. Is everybody okay there? Okay. If you're not, please speak up and we can elaborate some more. We can explain some things. But these are ideas that we've kind of seen before to some extent, so I'm still kind of going through them kind of quickly, because my hope is that once you get to the homework, this will start. You'll really figure out what you know and don't know, and then we can talk more about it at that point when we do questions and whatnot, right? Okay. The last kind of problem that I'd expect you to be able to do is if I give you a graph and I actually want you to graph the transformation of that. Okay? So that's the last kind of skill that we need to address here. So if you're given some parent function, we want to graph some transformation of that. So the idea is we're going to take our ordered pairs from f of x, and we're going to transform them into the corresponding ordered pair in g of x. Everybody okay with that? In general, that idea. We haven't talked about how we're going to do that yet, but that's our plan. So the way we'll do that is through this following function map. So all I'm going to do is I'm going to take my ordered pair from f of x, and I'll multiply the x coordinate by b and add h, and multiply the y coordinate by a and add k. So this is going to be my big tool that I'll be using, is this generic transformation map. So let's say that we have this as our function f of x. Everybody okay here? So this is like our parent function. And let's say we want to then graph this transformation. So the first thing I'm going to do is identify the values for a, b, h, and k. Who can tell me the value for a here? 2, right? So just the tool that we're using, again, that 2 is absolutely the correct answer, but if you weren't sure how we got 2, again, I'm just using the generic form for a transformation and just looking at the equation that I'm given, the function I'm given here, and using that to pick out the values. So a is 2. Everybody okay with how we got that? What's the b value going to be? 1, right? So here's my 1 over b. Notice there's no coefficient here. If there's no coefficient, that b value must just be 1. Very good. What's our value for h? -3. Remember, the h value is always the opposite of whatever it appears. The reason that is because we have the minus sign that's built in. So if I plug a -3 minus a -3 gives me the positive. And then our value for k is just -1. Everybody's good with that? So I'm going to use that then to make my transformation map. So that's b times x plus h, and then a times y plus k. Everybody's okay there? Again, just using this transformation map that I gave you guys a second ago, plugging in my values for a, b, h, and k. Okay, so I have 4 points on my graph. So I'm just going to copy those down here. And I'm just going to apply that transformation map to each of these points. So when I do that, I get -5, -1. Everybody's okay there? So here I have 1 times 0 minus 3, comma, -2 times, +2 times -2 minus 1. So that's -3, -5. And I have 1 times 2 minus 3, comma, 2 times 0 minus 1. So that's -1, -1. And my last one, 1 times 4 minus 3, comma, 2 times 4 minus 1. And that is 7. Yes, of course. So what I can do with that then is I'm going to just go back to this original function up here, and I'm going to plot my new points. So -5, -1 is over here. And then like -3, -5 would be down there. And like -1, -1 would be there. And 1, 7 would be up there. So I have something that kind of, oops. That's supposed to look like it's slightly at a different angle like it does over there, but you guys get the gist of it. So my new graph is going to look something like this. Is everybody okay there? Right, not too bad. So that's it for chapter 1. So you guys should be able to finish up the 1.8 homework. That's going to go from 57 to 66. Okay there? So the rest of chapter 1 would be due on Sunday. So that's going to be sections. What did we leave off on? Do we check through 1.4? Is that what we did on Sunday? Or is it through 1.6? I don't even remember. 1.6, okay. So 1.7 and 1.8 are going to be what I'll be checking on Sunday. Okay? As was mentioned earlier, we have a work from home day on Thursday this week. For the work for home day, I'm going to just ask you to do the review for the chapter. So if you look either on PowerSchool or in the content library, I've posted the chapter review. So you're just going to work on that on Thursday. There's no new material. There's no new instruction. There's no Zoom meeting. There's no video to watch. You're just working on the review. When we meet next week, we'll take questions from the review, talk about what the test format will look like, all that good jazz. If there's time permitted afterwards, we'll start on the next chapter a little bit, and we'll take the test the following class day. So the end of next week will be the test day for chapter 1. Does that feel okay to you guys? So that gives you a couple of days to get some questions answered and to work on the review and all that jazz. And I think all those dates are up on the calendar already.
So on like Wednesday we'll review together. Not the test day.
So that when we get back next week, do we meet on Wednesday is our first day? Yeah. So yeah, we'll take questions from the review. We'll talk about the test format, all that kind of stuff. If there's time still at the end, I'll start the next chapter maybe a little bit. And then the class after that would be the test day. Yeah, if we're in the first class is Wednesday, the next class. I'm bad at predicting like 3 classes out what day of the week that's going to be on, but it's on the calendar.
Okay.
I already put it on the Google Calendar, so I try to get that stuff to you when I have an idea of when it's going to be. If I haven't announced it in class, you can assume it's a soft deadline. If there's something up that I didn't realize, you can let me know, and we can always move things around. Not opposed to moving things. Okay? But I'm done with it. I'm done with things today, so you guys are ready to chillax on your own.